Hello, welcome to R&D Mathematics. Today we are going to talk about functions. Now first we need what is known as a relation. A relation simply is a set of ordered pairs. Now that means, first of all, an ordered pair is something like this. So say A comma B, that is an ordered pair. So there is an ordering and it's a pair. So XY, AB. So in this case, see, this is an example. So it's a set of, so set means, see, it's a collection of such elements. Now if I take the left hand side elements 1, 3 and 4, put it in a diagram 1, 3, 4, and right hand side elements here 2, 4 and 5. So what this means is 1 is related to 2, 3 is related to 4 and 4 is related to 5. Simple as that. So for example, it can be like this. You may have questions. So 1, 2, 1, 3, 2, 8, 10, 5. So if I draw this now, left hand side elements 1. Now we have a question. Do I write 1 again? No, you don't, because just one is enough. And then see this, we are done with 1, 2, 10. And they are related to 2, 3, 8 and 5. So 2, 3, 8 and 5. Now how do I do this drawing? 1 to 2 and 1 to 3. 2 to 8, 10 to 5. So there is no any rule, any restriction on how they are ordered. Also about this, all these things are relations. So now this one, left hand side, right hand side. Left hand side you have 3, 8 and 7. Right hand side you only have 5, right? And yes, that is also a relation. Now normally in a relation, this left hand side we call it domain, and right hand side we call it range. Remember these words, domain and range. Now we are in a position to give the definition of a function. Now let me write down the definition. A function relates each element of a set well known as domain with exactly one element of another set known as range. Now please read this carefully. Please read this carefully. Pause the video, read this carefully and decide. I'm going to draw 3 relations now. Relation number 1, relation number 2, without writing down, A's and B's or 1's and 2's, without writing down numbers. Just I'm going to draw these 3 diagrams that you must, it will give you a nice idea if you remember this, and you will remember this for the rest of your life. Now read the definition carefully and tell me you can You can't tell me because this is a video, but now out of these three relations, first of all, yes, they are all relations. I just explained it. Now, reading this definition, which one or which ones is or are functions? Okay, assuming you have an answer, let's go one by one. Now, let's read this definition carefully. A function relates each element of a set with x. So, we have two sets in each case. Okay, that's correct. Domain and range. You know what? Let me write down. Normally, we write down D for domain, R for range. So, D, R, D, R. So we have a domain, we have a range of all these three things, all these relations. Let me make a note. All of these are yes relations. That's for sure. What about functions? Now, each element of a set with exactly one element. Now we have to be careful. Now let's take the first one. This guy. So let me now draw whatever those things. They can be numbers, letters. It doesn't matter. Now first one. Each element, okay. Exactly one element. Yes, that satisfies. So number one is a function. This is a function. Function. Number two. You know what? Let me go to number three. Number three. Now this is the place it can be confusing. Now here, this one goes to this one goes to this one goes to this. That's okay. But here, each element of a set, okay, this guy, let me now give names A, B, and C. A goes to, let's call this guy D. A goes to D. So each A goes to D, exactly one element. B goes to also D. C also goes to D. Now again read this definition. Each element. So A, yes. A only maps to one element, right? D. B again maps to 1. It's the same element, but nothing is said about in that definition about that. So B also maps to one element. C also maps to one element. So yes, this is also a function. 1 and 3 are functions. So how about D? So how about second one? Now in the second one, okay, these three places, last three places, there's those. Okay, but here, right here, we have a problem. This element does not map to exactly one element. It maps to three elements. That cannot happen. So that is not a function. 2 is not a function. Now, in order to remember this, not just to remember this, there is another nice definition. See, first one, it's not just a function, this is one-to-one function. The reason one element goes and maps to one element and another element does not come to that element. So we have this one-to-one relation. And one-to-one relations is a function and it becomes a one-to-one function, and then we will be talking about that in a different video. And the third one, many-to-one. Many-to-one, it can be 2-to-1, it can be 3-to-1, it can be a combination of 2-to-1, 3-to-1, and any other number. Many-to-one relations are functions. Here also, one-to-one relations are functions. Actually, the functions, we also call them one-to-one functions. And the middle one, let me write it over here. Middle one to many. Yes, that is a relation, but one to many relations are not functions. Okay, that is the first and one of the most important thing that you need to remember about functions. Now we can get a little technical. We normally use this notation for functions. So this is notation. and we read is f of x, but sometimes we call it fx, but f of x is the correct way of saying it. The function is like a machine. For example, let's say you have this machine, you put your x, and what comes out, f of x, because the function is f. So for example, if your function, let's say function, let's see some example, if your function is x plus 1, so your function is x plus 1, f of x equal x plus 1. If you throw 0 here, what comes out is 0 plus 1, which is 1. If you throw negative 1 here, what comes out is negative 1 plus 1, which is 0. If you throw 100 here, 100 plus 1, which is 101, right? If you throw this guy, well, in general you cannot. There are things that you can put into your function, but in order to understand this is a nice way. Think about this. So f of this guy, now what is f of that guy? That is that guy plus 1. That is the form of our function, right? Now let's see more examples. So let's evaluate some functions. So let's say f of x equal to x plus 5. I want you to evaluate this quickly. So what you need to do, just put 0 in the appropriate place. See, this is the form of the function. This remains unchanged, these numbers 2 and 5. But x as the variable, when it changes, here 0, here negative 1, and here 3. And then this is 5, this is negative 2 and 5, 3, this is 6 and 5, 11, right? Simple as that. Now at this point you have to be careful. How about if I ask you f of t? Yes, now instead of x, just t. So 2t plus 5. That's the best you can do. How about f of 2x? Well, so 2 times. Instead of x, now you are inputting 2x. So x is replaced by 2x. So 2x plus 5, which is 4x plus 5. Now this idea is really helpful when we are dealing with compositions of functions. So that's why I'm doing it here. For example, you can put whatever you want, like you can put another function inside that, f of g of x. So that's the idea behind composition function. In this case, if my function f is 2x plus 5, so f of g of x, whatever g is, it's going to be 2 times, still the same shape, but you put just gx. So this is the best you can tell at this point, 2gx plus 5. So f of house, 2 of that house, plus 5. That is the idea, guys. Okay. And the places, let me do one more example. So the places where you have to be careful about, let's say, x squared minus 1. In this case, if you were asked to find this value, you really need the help of parentheses. See, squared minus 1. This is the shape. So now you have to put negative 3 inside that shape. A common mistake in a square function, common mistake is like this one. Students will do this. And okay, negative 9 minus 1, and you get negative 10. This is wrong. So the answer is 9 minus 1, which is 8, because you missed the parentheses. Remember, x squared. X is squared, right? Now, how about this? A different function, negative x squared minus 1. See, these two things are different. The students mistakenly doing g of negative 3 here. Because if you find g of negative 3, that is negative and then negative 3 squared minus 1, which turns out to be negative 10. Okay, so that's about function notations and evaluating functions. You know what? Another one. So let's say f of x equal 2x squared plus x plus 7. And I believe you can easily evaluate these numbers, right? So, but how about this? With so many variables, x plus h. Again, guys, so x, 2 variable squared, variable plus 7. This is the form of the function, and now your input is x plus h. So what you need to simply do, x plus h, x plus h, and then simplify. Let me quickly do that. 2 times x plus h squared, a plus b squared is a squared plus 2ab plus b squared. So this is going to be x squared plus 2xh plus h squared plus x plus h plus 7. And now terms, similar terms. We only have one x squared, so 2x squared. And here 2 into 2, 4xh. And here 2h squared. And from here x plus h plus 7. I think that's all we can do because all the terms are different. Yes. Okay, guys. So I think that's an introduction for functions, and then next we'll be talking about domains, range, and then one-to-one functions. We slightly talked about one-to-one functions, and then finally inverse functions. Okay, thank you.